quick volume check. Volume check. Volume check. Okay, let's get started so we're not here too late, everyone. I know there's a football game today. Trust me, I know there's a football game. Number one, evaluate the integral. We're integrating 3x cubed minus 2x squared plus 5 dx. So what I like about this problem is that it's a nice introduction to how the heck do we find integrals. So again, remember the rule for the powers is add 1 to the power and then divide by the new power. So we're going to take each one of these addends separately. So the first one is 3 times 1/4 x to the 4 minus 2 times 1/3 x cubed plus 5x plus constant. Again, add 1 to the power and then divide by the new power. So when you simplify that, you get 3/4 of x4 minus 2/3 of x cubed plus 5x plus constant.
Freudian?
Yeah.
Do we actually have to put plus constant on?
Yes, you do. Okay. Question 2. We're going to evaluate the integral now. 4 plus 5x to the 3/2, everything divided by x to the 1/2 dx. Okay, so what I was saying in class is there is no quotient rule for integrals. There is no product rule for integrals. So if you ever see a quotient like this or a product, that means that there's a trick, meaning you have to do some simplification or you have to use a substitution. In this case, you have to do some simplification. So the simplification, I think the easiest way to see it is to look at it like this. This is the same thing as 4 over x to the 1/2 plus 5x to the 3/2 over x to the 1/2. This entire sum integrated. Okay, we have that. Next thing to do is to simplify that so that you can just utilize the power rule. Remember, there still isn't a quotient rule. So that's 4x to the negative 1/2 plus 5x to the, let's see, 3/2 minus 1/2 is 1, so the first power, dx. Okay, we have yet to integrate, so we're going to integrate now. Now that everything looks like a polynomial, add 1 to the power, and you get 2. You get 1/2 positive, so you're going to multiply by the reciprocal of the new power. Add 1 to the power, you get 2. You're going to multiply by the reciprocal of the new power. I said the reciprocal of the new power. Did I say Ija? Ija? Yeah.
Why is it 4 times 2x?
Okay, the 2 comes from the reciprocal of the new power.
Oh,
Okay, and, oh, sorry. I would have to mark myself wrong. Plus constant. That's equal to 8 root x plus 5/2 x squared plus constant. Great. Let's take a look at number 3. Question 3. Okay, so I'm looking at this, and I'm supposed to figure, and I have from 0 to 9, 3 to 9, and 0 to 3. And I'm getting that by looking at the limits of integration. Again, the limits of integration, 0 to 9, 0 to 3, and 3 to 9. And so I think the way I want to illustrate this is just to kind of put this in order. And the properties...
Sorry.
It's okay. The property says that if I add 0 to 3 to the integral from 3 to 9, I would get the integral from 0 to 9. And again, that comes from an examination of the limits and just trying to make sense of those limits. How do they go in order? Okay, now I'm going to substitute things in. Okay, so I don't have anything for 0 to 3, so I'll have to be satisfied by just rewriting it. 3 to 9 I know is -1. That was given to me. And then 0 to 9 was given to me to be 5. So it looks like the integral from 0 to 3 has to be 6. I mean, that's barely a calculus problem, right? You just have to make sure you get the numbers in order. 0 to 3, 3 to 9, 0 to 9. How are we doing so far? Any questions? These are the easy ones, right?
Wait, how do you know what the order is based on what number?
Well, I'm kind of just putting them in numerical order, right? 0 to 3, 3 to 9. Making sure there are no overlaps. Question 4. Okay, so we have f of x equals... I'm seeing a lot of people do this problem inefficiently. Or I'm seeing a lot of people doing this problem in a way that's going to get them the wrong answer eventually. So I'm supposed to find f prime, right? And I don't see a lot of people taking the extra step to do this. Just write it out. If you just write it out, it's going to look like the fundamental theorem of calculus, which this question is actually trying to test. This isn't about can you integrate a polynomial. This is about do you understand the fundamental theorem of calculus. So let's just kind of refresh what we need to do. If we take the derivative of an integral, we're going to substitute the limits and then multiply by the derivative of the limits. I'll do that now. Substitute the limits. X squared cubed plus the square root of x squared multiplied by the derivative of the limit, okay, minus substitute the limit times the derivative of the limit. That's the fundamental theorem of calculus.
If on the test you just kind of like substitute x squared and find the derivative and multiply it instead of writing all that out, is that fine too?
Yeah. Okay, and let's see. Derivative of x squared is 2x. X to the 6 plus x. My gosh, do I distribute or do I factor? That's it. That's it, actually, right there. Yeah, that's what I did. Scroll up a little bit.
Well, do we have to write everything out, or can we kind of just...
It's a multiple choice part.
Okay.
Can you see that? Do I need to scroll up more? Okay. Quick pause. I'm told that if you're driving and you need to stay awake, like you should buy a hot drink and a cold drink and alternate. Yeah.
The minus 1 part,
Yeah.
where is that going in the answer?
The derivative of 1 is 0.
You're right. I understand plugging in, but I don't understand why.
Okay, let's move on then. Question 5. I think question 5 is an average question. Every average that we do in calculus will have an integral. This is no different. So we're going to integrate. The average is equal to 1 over b minus a, which is 2 minus 0, times the integral from a to b, 3x squared minus 2. Perfect. Okay, that's 1/2. And we'll have to do the method of antiderivatives. Okay. So that's 3 times 1/3 x cubed minus 2 times x from 0 to 2.
So wait, you add 1 to
Mm-hmm.
the x unit,
Yep.
3,
Yeah. Precisely. Oh, right on. Let's substitute and solve. Oh, you know, before I substitute, I'm going to simplify. I think that's pretty nice. That's 1/2 minus Yeah, it's supposed to be a 2. You know, it's gonna be so nice once we leave this chapter and I don't have to do these integrals, like show every step. That'll be really nice. That 2?
Yeah.
All of that for 2. Hate it.
It's the worst when it's like 0.
Hmm?
It's the worst when it's 0.
It's true. You know, I make fun of 0 all the time, but in truth, 0 is actually a pretty profound thing. Pretty profound concept. Okay, letter number 6. Wow. We got this table. Got this table, man. And we're supposed to approximate the area using a right rectangular approximation method. Let's make a table, huh? Here we go. X. What's my first interval? 0 to 0.5? What you doing, brah? Yeah, I'm making a table right now just to organize my thoughts. 0.5 to 1. Next one is 1 to 3.5. Last one is 3.5 to 5. 3.5 to 4. And then 4 to 5. Then it stops. Okay. First thing is the width of each rectangle. 0.5, 0.5, 2.5, and 0.5. Okay, the next thing is the height of the rectangle, which is going to be from the right side because it's a right rectangular method. So on the right side, at 0.5, the height is 2. At 1, the height is 2. At 3.5, the height is 8. Whoa. At 4, the height is 5. Okay. Yes.
Using the right rectangular method, you just subtract the second x in each interval by each other.
Yeah, second x from the first x in each interval.
So
That'll
right
give you the width.
left would be the first one.
No. Okay, so the right refers to where do you get the height from? Let's take a look at the first interval. The first interval is from 0 to 0.5. A right rectangular method means that the height's 2. A left rectangular method would mean the height is 9. From the chart. Look at the chart. Left rectangular method means the height is 9. Right rectangular method means our height is 2.
Is the left the first one? Okay.
Exactly. All right, so the height is equal to 0.5 times 2 plus 0.5 times 2 plus 2.5 times 8 plus 0.5 times 5. That's it, right? Great, 24 and a half. I love it when my program does math for me. Especially that kind of math. Ugh. I'm trying to remember when I stopped multiplying by counting. When did I stop doing that? It was in high school for sure. I think I was in calculus A and I was still going 8 times 5 is 5, 10, 15, 20, 25, 30, 30. Yeah, I think. 81. No. Eight times 2, 27. 8 times 3 is 27. Seven. Trapezoidal rule. Okay. Now this is confusing, right? Because we need to divide this into 4. We need 4 equal trapezoids. Right, so we need 4 trapezoids in the interval 0 to 7, right? So basically the question is, how wide does each trapezoid need to be? Each trapezoid needs to be 7 minus 0 over 4, which is equal to 1.75. Okay? Each trapezoid needs to be 1.7 wide, 1.75 wide. So let's make our table.
Do they have to be equal intervals?
Yeah. I think that was the implication. These had to be equal intervals.
Do they always have to be equal intervals?
No.
How do you know if they're not?
It should tell you.
Are you gonna pull one of those on us?
Well, I already did.
Where?
Right here. These aren't equal.
Oh, is it trapezoid?
Well, if these were trapezoids, it would be not equal.
Okay.
Hmm?
When it says n equals to 4, that means the number of trapezoids.
Yeah, n equals 4 means 4 trapezoids. Where am I?
Making it
N equals 4. Neat. Means 4 trapezoids and 4 rectangles. Okay? Alright, so we're gonna go back here, we're gonna make our intervals. Second interval is 1.75 to 3.5. Next one is 3.5 to 4.75. 5.25. Last interval is from 5.25 to 7. Great. Oh, you know what? Can I do this first? I'm sorry. Let's make a table of values. Okay, so what is f of 0? 0. What is f of 1.75? Oh, you know what? Let's just do this on our calculator. I'm sorry. We're going to do this on our calculator. Are we ready? We're going to make a table of values on our calculator, then we're going to transfer them to paper. So sorry, I forgot that we could do this.
But we can't use calculator for this part.
You can't use a calculator in this part?
It says only for problems 15 through
You're right. Sorry. Okay, no, real talk. You need a calculator in this part.
So are we gonna
Wait, why can't you plug in each one? Why can't you just plug in each one into x squared minus 7x?
Yeah, you can. We're gonna do that.
Using our calculator.
Yeah, use our calculator.
So are we gonna be able to use it on the calculator?
If you need it, I will have it. Don't worry.
Okay.
It'll all be taken care of. It will all be taken care of.
Okay.
Y equals. Let's clear off. Sorry. When you need the calculator, trust me, I will let you use it. So this is what, x squared minus 7x. You got that? Okay. I want to show you the real quick and easy way to evaluate this function several times. Here's what you do first. You go second window. Okay? You're going to scroll down till you see independent. And you want to change that to ask. Independent ask. Again, this is an improvement on the old calculator way. Then you're going to go second graph. That'll get you at the table. Ooh. What's the first value of f of x we want to evaluate? 0. Put in a 0 and then enter. What's the next one? 1.75. Put 1.75 and push enter. What's the next one? 3.5. Good. Put 3.5, push enter. What's the next one? What's the next one? 7. Good. Okay, so basically your calculator evaluated all of those really quickly. It gave it to you in a table, so you can just copy that down now, right? Negative 9.1875. Did I get the wrong numbers? I just wrote it wrong? What do you mean? Yeah, don't round it. Wow, don't round it.
It rounds it.
It rounds it incorrectly for you all the time. Negative 12.25. Negative 9.875. 0. Okay, everyone. Continuing with our chart. The width of each of these intervals is 1.75. Okay, so now the height of each one, that's going to be the average, right? 0.5, and I'm going to write it here like this, times f of 0 plus f of 1.75. Next one is going to be half of f of 1.75 plus f of 3.5. The next one is f of 3.5, no, sorry, 0.5. F of 3.5 plus f of 5.25. Last one is half of Okay, that's not a very enticing calculation, is it? Okay, let's put it all together. So that means the integral is going to be equal to, let's see, width times height, 1.75. Hey, is it okay if I factor out the 1.75 from all of this? Good. And the 0.5? Sure. Might as well. F of 0 plus f of 1.75 plus f of 1.75 plus f of 3.5 plus f of 3.5 plus f of 5.25 plus f of 5.25 plus f of 7. That really brings you into the trapezoidal rule quickly, doesn't it? I'm not quite sure what you're asking. Oh, because those are factored. Remember what you're doing is you're multiplying these two together and then adding, multiply those two and then add, multiply those two and add, multiply these two and add. Is that? It's okay. You got this. You can do it. All right, I'm going to push the equal sign. Hopefully my calculator will give me a good number here. And it doesn't. Oh, because I put f of 0. My calculator doesn't know what f of 0 is. I'm saying my calculator doesn't know. What do I get? Is that rounded? Don't round it. Do not round. 53 point how much? Yeah, I'm not very happy about that. Oh. Do we need more time, or can we move on? Sure. A little more time, that's fine. All the time in the world. Okay, not really. I told Mrs. Ferry I'd be back at 5:30. We need to go shopping. Yeah, we got to go to Trader Joe's and then 99-cent store.
Do you always shop together? That's
Unless I'm out of town. Did you figure it out, Lisa? Did you figure out Aisha?
Now I got negative 61.25.
Can I see your calculator?
such a genius.
My calculator's retarded.
Ah, you're missing a parenthesis.
Where?
Wait, so hold on. Why are you... Oh, yeah, okay. All right. You need a parenthesis there.
Didn't I put it?
Because you want to multiply this with the entire sum.
Oh.
Bam!
Wait. Okay, you took the parenthesis off the 0.
No, I didn't take the parenthesis off the 0. I added an extra parenthesis in front of the 0. Because look, you have to multiply this by this entire sum. It's this times
Got
this
it.
times this.
Got it. Alright, gracias.
Hey,
My calculator, I put in the values and then I hit second table and then it already has values there.
yeah. If you want to have it so that you can do it on call, you put this on independent. Oh, you didn't.
So now you go second table. It already has values from -2 to
Okay.
4.
Well, you can just delete them all,
And then it's
and then you can start over again.
perfect.
Okay.
Thank you.
You're welcome. Are you ready to move on? Yeah? Yeah.
I got negative 54.0. I got error.
Bring me your calculator. Let me see. Your calculator. You said you got negative 50.
Because you see, isn't it 9.1875? I did that 4 times because there's 4 of them. Because that's the F
Okay.
of...
I'm going to ask you not to do calculations this way.
Okay.
Okay. Do them all like in one line. 1.75. So really, 1.75 times 0.5 times, and then now do that, okay? 0 plus, you said 4 of them?
Yeah.
4 times,
Negative 9.18
plus,
negative
2 times,
negative
12.25, right?
Yeah.
2 times 12.25?
Oh, I know what I did. I thought it was 12.5, so I was off by head.
Okay. Yeah, try to do everything in one line because it's easier to catch the error that way. Okay? Trust me.
I mean, you're supposed to. It's so. I just like I
Not exactly. You're better off just look at one trapezoid at a time. Okay? Don't try and get the general rule. Just do one trapezoid at a time.
What I did is I did times 1.75.
Okay, let's take a look at number 8. Take a look at number 8. I know that was kind of confusing. It's one of the places where we're... Well, never mind. Number 8. Number 8, we have the average value. Really? Now? No. Did she say Akira or Shakira? Lakira. Shakira's, those hips don't lie. Sharon says. Okay. All right, average, average. Remember, an average must be an integral. This is calculus. Average equals 1 over b minus a, which in this case is pi halves minus pi quarters, multiplied by the integral of the function, which is sine x, right? Perfect. You should be able to do this by hand. This is equal to 1 over pi quarters times, what's the antiderivative of sine?
Negative cosine.
Negative cosine. Very good. Negative cosine x from pi quarters to pi halves.
Wait,
Yes.
why is it negative cosine?
Because the derivative of cosine is negative sine.
Okay. Should it be positive? But isn't the derivative of sine cosine?
Yes, it's true.
Should it then be positive?
We're not taking the derivative. Four over pi. Negative cosine of pi halves minus 4 over pi.
That's a 4, not a 5.
Negative cosine of pi quarters. Kind of like that.
I can't see it.
Equals 4 over pi. I'm going to make sure I write a pi this time. Times 0 minus 4 over pi. Gosh, it's a good thing that you memorized that unit circle. Pi over 4, the x coordinate is rad 2 over 2. Gosh, you're so good. You're so good. It's amazing. Therefore, the average equals 4 root 2, no, 2 root 2 over pi. Two root 2 over pi.
Yes.
That's sweet. Any questions? You know, having you all memorize that circle, that's probably the best thing I've done all semester. Yeah.
You had 1 minus a, 1 over b minus a. You got pi over 2 minus 3 pi over 4. Isn't that negative 3 pi over 4?
One more time.
You had one on the question before. You said pi over 1 over pi over 2 minus pi over 4.
Yeah.
How'd you get pi over 4?
That's pi halves minus pi quarters. So that's like 1/2 minus 1/4.
Isn't that equal to negative pi over 4?
When you turn that to an LCD, that's 2 pi over 4 minus pi over 4. Got it? Awesome. Number 9. Again, there are no quotient rules in integral calculus. There are only... Sorry, I lost my train of thought. There are no quotient rules. There's probably a trick. What's the trick for this one? Split it up. Right, you don't have to split it up, really. You're right. You're right.
You get pi over, yeah, pi over 2. Just 2 pi
Okay. 1/3 x cubed minus 1/2 x squared plus constant. I'm going to wear my plus C t-shirt on Monday, don't worry. Samantha made me one last year. Samantha and Kevin and Danielle. I like 4 or 5. No.
So when do we put plus C?
Whenever it's an antiderivative. If it's a definite integral or area, there's no need for you to put a plus C. Make sure you do C.
So basically when there's no bound. So basically when there's no bounds.
Yes.
Then you put a C.
10.
When there's no bounds, you just put the C. No, but okay, but if there were bounds, you would find an actual.
Yeah.
If there were bounds, you would find the antiderivative and then plug both of them in and subtract it, right?
Yeah.
Because there isn't, that's just your final answer.
Exactly. Okay. This is the time when we talk about, did you memorize your Pythagorean trig identity? Yes, you did. They're right behind me. This is 1 tan secretary, right? Good. So the 1 plus tan secant squared. Good. So on the test tomorrow, when it's 1 plus cotangent, what were you just saying? I didn't.
You said if it's 1 plus cotangent, but it has to be 1 plus cotangent squared.
You're right. Okay, simplify. You know, part of me thinks that the reason why math teachers like to use theta instead of x when we're talking about trig functions is because they don't want the Freudian slip for secant. No, we will not have the Freudian slip. For secant? I did. I do it all the time. I'm a Freudian. You know what? Is there a band? That's a good band name, the Freudian Slippers. No, the Freudian Slippers.
At Pierce College, they have like this called the Freudian Six.
Exactly. Fuzzy slippers with like a picture of Freud on top of them.
Yeah, or like a bunch of training devices.
Yeah, you're right. There is. Sorry. Antiderivative of secant tangent. Yeah. This tangent here, that's from this tangent here. I can't believe my Freud joke is that popular. Okay, everyone, we need to keep it together. We have 5 problems. We need to keep it together. We have 5 problems, okay? I'll try and keep it together too. 11. 11. Okay, so 11 is kind of, it says there are multiple answers, right? So in days past, before I put there are multiple answers, I got a lot of questions about this, as in why can't I do this, why can't I do that? And basically the answer is, well, there's one thing that I want to make sure you don't do. Okay, do not do this. Don't do this. The integral of f of x, g of x, dx is equal to the integral of f of x times the integral of g of x. This is not true. Okay, don't do that, okay? Okay, this is wrong. This is wrong.
What is right?
Remember what I said. There is no product rule for integrals. You cannot break up a product. There is no product rule for integrals. Okay? You can, absolutely, no problem. You can turn this into the following. You can separate. That's fine. Heck, you could even well, you can even just separate the last two functions. Heck, you can even do that. Okay? That's fine. Heck, you could even factor out a 7.
For the test, will we have to know how to do all of these?
When you take out a 7 and yeah, I guess
You
you could do that.
could do that.
How can you cross 1 7 and not the other one?
Oh my gosh, you're right. That should be a 7 and not a 1/7.
And then, yeah.
Wow, over
Heck, you could do that. Okay. Let me tell you what I'm preparing you for here. This is a multiple choice question. The question's going to say which one of these is a correct, which one of these is a correct, or is equivalent to?
Are you having all of the above?
Which one is equivalent?
That would be cruel if you have all.
Okay. Any one of these is correct. You know, there are actually an infinite number of these that you can create. I can't possibly do an infinite number of them, but I think giving you 3 or 4, that's gonna be should be enough.
Can you go back up to see? Yeah.
That is wrong. Don't ever do that. It's cool.
I have a physics test on Monday, so it just keeps.
Yeah, no worries. Yeah. Josh, are you done with this line?
Yeah.
That's it. Just pick the one that's equivalent. The one that's equivalent. Not always. A what? Fold, and then you fold the wings. Open. Make a, yeah, fold those down. And then fold it down. Fold the point down. No, the point. And then fold it down again. Make the arrow. Make the point again. Fold it back. Fold it up. No. Okay, let's do this. We're about to finish. Number 13. Number 12. Fundamental theorem of calculus. Okay, I know it says fundamental theorem of calculus, so that's kind of confusing. Okay, are we taking the derivative of an integral here? Look at the question. Is this the derivative of an integral?
No.
No. That means this must be the the integral of an derivative, right? Okay. This is the integral of a derivative. Okay. What is the antiderivative for t to the 1/3 power? What is the antiderivative of 2? Negative 1 to 1. Good. That's equal to 3/4. Oh, no. 3/4 of 1 to the 4/3 minus 2 times 1 minus 3/4 negative 1 to the 4/3. Ooh, that's going to drive you crazy, right? Minus 2 times negative 1. Let's do this. 3/4 minus 2 minus 3/4 plus 2. Okay, that is 3/4 minus 2 minus 3/4 minus 2. Oh, look, it's negative 4. Negative 4. Yeah, make sure you distribute the negative. The people who make tests are very good at knowing that you're not going to distribute the negative.
It's like all algebra.
Huh? Oh, 3/4 minus 2 minus 3/4 minus 2. Negative 2 minus 2 is negative 4. Distribute the negative. Yeah, it is. Right there, positive 2. You still have to distribute the negative. I don't know. Two more problems. Two more problems. 13. Huh? Okay, you know what I'm going to do for number 15? Is I'm going to rewrite this in descending x order. 13, I'm going to write this in descending x order. That's x squared plus 6x plus 5 over x plus 5 dx. See, I don't know why it is, but when you write it in ascending x order, all of a sudden all your algebra goes out of your brain. Or for a lot of students, all of a sudden they look like they don't know how to factor that anymore. Hey, this is just like when you were doing limits, isn't it? One of the tricks is to factor and simplify.
Yeah, and you find a hole.
Right? Good, 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 good. What's the antiderivative of x? What's the antiderivative of 1? Okay. Let's see, this is equal to... No, I can't go that fast. I mean, I can go that fast, but there's someone in class who's not going to be able to go that fast.
I've actually already did this, so.
Okay. Let's open this up and simplify. That's 25 halves plus 10 halves minus 9 halves minus 6 halves. Isn't that clever, putting everything over 2 right now? How clever. I'm such a clever... No. 25 plus 10? 35 minus 9? 26 minus 6? 20 over 2? Oh, Eliza. Aisha. Aisha.
Okay, no, I think this is Elijah. Which is weird because the same when you search it.
I think she's just screwing with you.
Actually, what should my name be when I walk into every college? Dan. Why? This is the easiest name. You know what's funny? There's Eliza Doolittle. There's Eliza Thornberry, and people still don't know that. Like, I didn't know any of them. Who knows Eliza Doolittle? Who doesn't know my family name? And you have to be that uncultured. They are they're at Starbucks.
There's Eliza from The King and I, too. Run, Eliza, run.
There's also Eliza from Uncle Tom's Cafe.
Oh, yeah, yeah. Actually, that's the same Eliza from Uncle Tom's Cabin. No, that's the same Eliza from King and I.
Oh, yeah.
I have watched The King and I have seen it.
Oh yeah, 14. Sorry. Sorry. 14. We're here to do a job. It's Friday. You guys have a football game. I need to go shopping. Consider. Ooh, okay, let's consider. Let's consider the integral from 2 to x. Oh no, no, oh dear. Consider f of x equals integral from 2 to x of 1 plus t to the 4th dt. We're supposed to find f prime of x and then f prime of 2. So, f prime of x, I said it earlier, take the extra step, take the extra time to write that d dx. Once you write that d dx, it becomes really obvious what you need to do. Once you write that down, it looks like the derivative of an integral. Please write it down. To find the derivative of the integral, you're going to substitute the upper limit. You're going to multiply by the derivative of the upper limit. Minus, you're going to substitute the lower limit. Yes?
Does that say f prime of x equals 1 over 1 plus x to the 4th?
And you're going to multiply by the derivative of the lower limit. If you know already it's 0, you don't have to write it. F prime of x is equal to 1 over 1 plus x to the 4th. Hey. Next, what is f prime of 2? It's 1 over 17. Look at that. Just plug it in. Which one? You're going to multiply by the derivative of 2. And the derivative of 2 is 0.
So first you have to find the f prime of x, then you just take this and put it in the f prime of x.
Okay. Good luck on Monday.